Okay, this is going to be the next video for trig proofs and verifications. We're going to talk about verify today. Okay, what verify means is we're trying to get one side equal to the other. So we're going to use the identities. Now we're going to work with the fraction part first. Okay, so what you should look for is are there any identities here? And what we figure out is that this right here, okay, we figure out that this right here can be substituted for cotangent squared of theta. Okay, so we know that basically this gets substituted for this. Okay, now, sort of talked about this the other day. You can sort of just leave that. You can use theta or x, does not matter. Okay, all right, I would do cotangent squared divided by cosecant squared. Okay, I'm just going to put the equal sign there. I'm going to rewrite cotangent as cosine squared over sine squared divided by 1 over sine squared. So I'm going to write them as those. Now remember with division, we're going to flip that fraction. So cosine sine squared, I got cosine squared and sine squared. And what I know is that those can eliminate. So I got cosine squared on this side, and I got cosine squared on this side. This is how you know you're good, okay? All right, so you're looking for the identity there, okay? You're looking for the identity, okay? Now, we don't see anything clearly as an identity on this one. So what I'm going to do is I'm going to rewrite this as 1 cosine squared. Write this as cosine squared over sine squared minus 1 equals cotangent squared. Okay? Now, we can do a quick eliminate here. So I'm left with 1 over sine squared theta minus 1 equals cotangent squared theta. Okay? Now, what I got is I've got a, I want to get a common denominator, so I'm going to have to multiply this side by sine squared and this side by sine squared. Okay? So I got 1 over sine squared minus sine squared over sine squared. Now, because they were common denominator, I can push those together. Okay? Now this part will be my identity. That is going to be cosine squared. Okay? All right? Now, how do I know when to stop? Well, I know this has to equal cotangent squared. And so this already equals cotangent squared. So I'm good. Okay? So go ahead and pause your video and see if you can figure out this one. Okay? Go ahead and unpause. All right, we don't have squareds here, but I'm going to go ahead and rewrite this. This is 1 over cosine. This is 1 over sine times sine over cosine minus 1 equals this side. Okay, so what I can do is I can quick eliminate there. So what's going to happen is that's going to be 1 over cosine squared minus 1 over 1. Okay, to get a common denominator, I multiply by cosine squared by cosine squared. Okay, so that's going to be 1 minus cosine squared. Okay, because I can push those together now. All right, and cosine squared. All right. All right, we know that that's going to be sine squared. This will be cosine squared. Okay, all right, and as I'm getting towards the end, I want to see that's going to be tangent. So this is going to be tangent. Okay, so that's a verification then. All right, let's go to the next type. Okay, so you got this fraction here. All right, now, what you want to do is get a common denominator, and this is how easy this is. I'm going to multiply by this side on the top and the bottom. Okay? So I'm just going to, just so my notes don't get all jumbled. So what I want to do is I am going to multiply cosecant of x plus cotangent of x by cotangent of x minus, I'm sorry, cosecant of x minus cotangent of x. I have to do that on the top and on the bottom. Okay? The same thing over here. I'm going to multiply this one by the plus version. Now, what's convenient about that is that's like a difference of squares. That's like a difference of squares. So the idea is, if I were to multiply x plus 5 times x minus 5, the quick thing you should know is that it's just multiply this times this is going to be x squared, this times this is negative 5, okay? Because they're opposite, I don't have a middle term. So what this is going to turn into, okay, I would distribute that up top. That's going to be cosecant of x minus cotangent of x. This bottom part is going to turn into cosecant squared minus cotangent squared. Okay, so plus, distribute this, that would be cosecant of x plus cotangent of x all over cosecant squared minus cotangent squared of x. Okay, now I can push those things together and combine my like terms. Okay, so what I would have is I'd have 2 cosecant, okay, because I got a cosecant there and a cosecant is 1. These would eliminate, okay? This is just cosecant squared minus cotangent squared, okay? All right, now, the idea is if I look at this, this is one of my identities. We know that this equals 1. Okay, and that is actually what our problem equals. So I got 2 cosecant of x equals 2 cosecant of x, okay? So basically this was an identity, okay? And that's how you do that problem, okay? Let's do another one together. Let's do another one, okay? So what I want to do is I want to multiply by 1 minus sign, okay? And 1 plus sign over here. So what this is going to look like, I would do cosine of theta times 1 minus sine of theta. That's what's going to happen up top. This bottom is going to turn into 1 minus sine squared of theta. I'm going to multiply by cosine theta by 1 plus sine theta. And on the bottom, it's going to be 1 minus sine squared theta equals what I have there. Okay, so if I distribute this, this is cosine of theta minus cosine theta, sine of theta. I'm just going to write it in alphabetical order. Okay, plus, if I distribute that, that's going to be cosine of theta plus cosine theta sine theta. Okay, all over 1 minus sine squared theta. Okay, now, as you notice, these two are going to cancel each other out. Okay, so I got a cosine and a cosine, so it's going to be 2 cosine. And then I know that this is one of my identities, so it is going to be cosine squared theta. Okay, now, we talked about this a little bit last time, that I can rewrite this stuff when it's squared. You can always rewrite it like cosine and cosine. So what happens there? That eliminates. So that's going to be 2 over cosine theta, okay, which is 2 secant of theta. So 2 secant of theta. So you just got to work through your algebra tricks for that, okay? I would like you guys to pause your video, okay? I would like you to pause your video and go ahead and see if you can try this one, okay? So what I would do is I would multiply by cosecant of theta minus 1. This one's going to get cosecant of theta plus 1. So it's basically what's going to happen is I'm going to get 1 cosecant of theta minus 1 times 1 over this bottom part will be cosecant squared theta minus 1 plus, I would take 1 and times it by cosecant of theta plus 1. And I do this one, this is still going to be cosecant squared theta minus 1. Okay, because the difference is squares. Okay, if I distribute that out, that's going to be cosecant minus 1 plus cosecant of theta plus 1 all over cosecant squared theta. Okay, now we know that these and this will go away, so I got 2 cosecant of theta, and I got cosecant squared theta. Okay, now what I can do is I can write this out, cosecant theta, cosecant theta, cosecant theta. Okay, so boom, boom, that eliminates. Okay, all right. Oh, whoops, sorry, I did that wrong. Let me back up here. That is not correct. Okay, this right here will be the identity. I was wondering where something went wrong. I knew I went wrong because I wasn't getting that. Okay, and what this is equal to, cotangent squared theta. Okay, so I got 2, all right, cosecant of theta, all right, over cotangent squared theta. Now, When I got a lot of stuff that those are not alike, I'm probably going to end up doing something like this. 2 cosecant of theta, okay, divided by cotangent of theta, cotangent squared. So I'm going to rewrite those as sine. So that's going to be 2 over sine theta divided by cosine squared theta over sine squared, okay? I'm going to continue to work here. So I got 2 over 2 sine theta times sine squared theta over cosine squared theta, all right? Now, what can basically happen, okay, I'm going to go ahead and write these out just nice and big so we can just work with this. Separate these out, okay? And what would happen is this would go away, okay? So I would have 2 up here, then I would have 1 over cosine of theta times, I'm sorry, I would have, yeah, got paused a little bit there. Okay, so I got, this would be cosine squared, which would give me my secant squared, times sine theta, it's going to equal the same thing, okay? Okay, reason this is cosine, okay? All right. All right, let's go on to the last thing. Okay, now for this, I'm gonna have to work with the fraction. It's sort of the same thing with difference of squares. What I'm going to do with this is I am going to try to create the difference of squares by whatever this is. I'm just gonna do the difference of squares for that. Okay, so what happens is that is going to be sine of theta plus sine theta cosine theta all over 1 minus cosine squared theta. Okay, I know that is an identity. Okay, so I got sine theta plus sine theta cosine theta over sine squared theta. Okay, now we talked about a little bit of a math trick where when you have the plus, you can separate this into 2 fractions. So sine of theta over sine squared plus sine of theta cosine theta over sine squared, okay? Basically, the long and the short of this is that I would be able to eliminate, okay, because I would have sine theta over sine theta times sine theta plus sine theta cosine theta sine theta, okay? All right, so what would happen is boom, boom, that goes away. That's 1 over sine. Boom, boom, that goes away. That's cosine over sine. Okay, so what does this equal? Okay, this would be cosecant, and this would be cotangent. And that's how I get my answer. Okay, so you're looking just to solve the next problem. Okay. Okay, let's do this one. So what I would do is I would take tangent of theta, secant of theta plus 1, and I would times by secant of theta minus 1. Secant of theta minus 1. So that would be tan theta times secant theta minus tan theta all over secant squared theta minus 1. Okay, now this is an identity here. This is going to equal tan squared. So I got tan of theta, secant of theta minus tan of theta all over tangent squared, okay? So the little math trick here is let's go ahead and separate this. Tan of theta, secant of theta over tan squared of theta minus tan theta over tan squared of theta, okay? Now I'm gonna separate the squares. Tan, secant, tan, tan, okay, minus tan, 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 okay? So what's going to happen here, this goes away, this goes away, okay? So I got 1 over tan, okay? All right, and now I got secant over tan, All right, now this one's a little bit tough. I'm going to have to break this down to secant divided by tan, or 1 over cosine divided by sine over cosine, which is 1 over cosine times cosine over sine. Those eliminate, it's 1 over sine. So that's how I got to that. And then I know that 1 over sine is cosecant, and 1 over there is cotangent. So that equals that. Okay, so a little bit tricky. Okay, a little bit tricky there. All right, let's go to your problem. I want you to try. Okay. All right, we are going to multiply by 1 plus sine. Okay, so I got cosine times 1 plus sine. I got this times this would be 1 minus sine squared theta. So I got cosine theta plus cosine theta sine theta. This is an identity. This would be cosine squared. So what I'm going to do is I'm going to split this cosine theta, cosine squared, cosine of theta, sine of theta over cosine squared. Okay, I'm going to expand the squareds. Okay, so I can eliminate, boom, 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 boom. Okay, so what I got here is I got 1 over cosine theta plus sine theta over cosine theta. Now, how do I know I'm done? What does this equal? This equals secant, this equals tan. So I'm good. Okay, those identities take some work. Okay, take some practice. Okay, all right, we'll go over them a little slower in class. I want to show you how they're done. You can obviously go back and drag the video if you need to practice any of those.